So find k, given that blah, 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 is a perfect square. So for us to do that, what does that mean if it's a perfect square? Times by itself, right? Yeah. Now, obviously, this bit here is going to be one of the keys because we would have to have 2x squared times, of course, itself, 2x squared. Would you agree? And then the other key is your 9. So that would have to be a 3 here and a 3 here. Now, where we can go a bit amok, does it have to be plus 3 or does it have to be minus 3? Well, it could be either. So that could actually be minus, minus, right? And then what's going to be in the middle? That's right. We don't know what it will be, so we'll have to call it bx. But lucky for us, because it's a perfect square and not just two quadratics times together, then the other one also has to be bx. And then we just do our normal equate coefficient and see what happens. I suggest that you do this one maybe second and try, oh, I'm an idiot. Why am I an idiot? Oh my God, this is going to be published too, and I've just said I'm an idiot. So, whoop, whoop. Try that one first, and then try this one. Okay? Because your options are, it could be both, or it could be only one of them work. That's why I said try this one first. Is that right from memory? That makes sense to people. So can you see how we're progressing now, where the questions that we started with were, oh, look, here's the expanded version with a missing piece, right? So one's like this. And then it's going to worded questions where you actually have to come up with this and then solve. And hopefully you're getting those skills a little bit. So if you don't mind, and I can save this in our, and I will save this in our OneNote, but that's just, I hope you go, oh yeah, I could now solve it if I have time, and I'll give you time tonight to try and not give you too much homework for those of you who want to finish it off. But what we can do is jointly see how we can get a start with some of these and then just keep trucking along because it's all interconnected. Is that okay? All right. So the other question that we had was about question 9. Write blah, 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 blah in this form where A, B, C are constants. Any takers on that?
Wasn't necessarily the finding a constant part that was difficult in it, or was the finding the zeros? The obvious one from the that is using the same thing as the example isn't one of the roots.
That one is interesting. I'd have to remember. I can't remember how to do the A, the B, the C. I would say, is there a possibility to pull out common factors? So I will do that one myself. Sometimes you have to sort of do them to. So put a pause on 9, but I'll hit that one. 10. What was the issue there? Oh, sorry.
Is there a mathematical way to do it or try it?
Yep. So, yes. So for A, okay. So with A, we've got x cubed plus x squared take 16x plus k has two identical linear factors. Find k and hence factorize. All right. So again, what does that mean if you've got two identical linear factors? There's a square in there, perfect square. Now, do we know what that perfect square is? No. And if you didn't really look at the question, you might want to go, oh, is it ax plus b all squared? But for us, we already suss that because it's a simple x cubed, we don't have to worry about this a because we already know that it must be 1. Okay, so far, we know, and I'm doing this with you guys, right? I still like to write down my questione. So, do we agree that one of our quad factor would have to be x? Do you want to go take A or plus A? Let's go plus. We'll keep it positive. Let's be positive. That's my blood type, by the way. Be positive. Just thought I'd share. Nobody cares, right? I am. How sad. Nobody watches it. It's all right. That was am I filming this right now? Yes. Okay, so x plus a all squared. We happy? And then what has to go over here? Yes, and we know that it's a linear. So what I'm just going to do is this is now going to be x squared plus 2ax plus a squared. Now, we know that this linear has to be an x. And you can have, this is an option. So sometimes it works out better, sometimes it's a disaster. So you could, as this linear factor in the last bit, you could have it as plus b. Is there anything else that you could have it as? You could have it as plus, I have to think now, a squared on k. Why could that be an option? When you expand, oh no, that's not right. God, and this is on video.
K on A squared.
K on A squared, see, because they were looking at me. K on A squared, right? Because when you multiply this by this, what's A squared times K on, those will actually cancel and you haven't got fractions. To be honest with you, I'd probably lean towards this one. All right? But remember, you have to try and get into the habit of sometimes your plan A might not be the best option. And don't be afraid to go, oh, this is starting to get a little bit messy. I'll try something else. And maybe it is meant to be messy. Who knows? Does that make sense? All right, let's put our heads together and just have a look then at B. So we're just getting starts on these. And as I said, I will give you time to finish off. And if you're sort of going, I don't want to mess up my book, I'll copy this and put it in the OneNote so you can see that it's there. It's too late. I mean, I sometimes, when I'm doing stuff, I don't mind if I'm wasting paper, so I will leave a whole column for a question. And then it's really clear. So I spread out my work. All right. You have a read of B. Now let's see, can we get a start there? So we've got from the class, isn't it just the same thing? Yes, it is. Okay, so it's that clue there of what's a identical linear factor. And I hope we now sort of go, oh, yeah, we knew that. Is that okay? Hey, Hamish, you know this is just for you, by the way. Hope you're okay. So we just had a query and we're going to be doing our long division. Okay, so we set it up as per usual. We're going x take 2. And then we're going to put the 2x cubed for plus 6x squared. All right, so where are we going to look first? We're going to look at our 2x cubed and we're going to ask ourselves, what do we have to times x by to make it 2x cubed? 2x squared, and we like to put, so here's my squared here. We're going to put that above, so we're going to go 2x squared. And now we're going to multiply our divider by, so we're going to multiply this by the 2x squared and pop it underneath. So 2x squared times x, 2x of the cube variety. And 2x squared times 2 is minus 4x squared. And we are subtracting. You know you've done it right if that first, the highest term, disappears. That's what you want. 6x squared, take 4x squared.
Now that would be a take negative.
Take. I was just testing them, which I was not. Right? Take becomes a plus. 6, take. The fun bit. Bring down. And you don't just bring down the 4, you bring down the sign that's in front of it. Okay, so now where do we look? Where are you looking? We want to get rid of this. Right? So what are we going to have to times x by to make it become 10x squared? 10x. And hopefully we're getting into the swing of it. We have to times that now by 10x. So we get 10x squared, and 10x times minus 2 is minus 20x. Sorry? Not yet. Don't get too excited. We have to do our subtraction first. I know that's the best bit, Tom, but we got to, so we can't, that was a, do we bring the 3 down straight away? Not yet. So 10x squared, take 10x squared is no x squared. Minus 4, I've learned my lesson. Take, 20 becomes plus 20, so 20 take 4 is 16. And now it's that good bit. We bring down the 3. What do we do now?
16.
So see here, now we're going to look at this 16. And we have to say, what do we times x by to make it 16x? And we pop that above. And now go 16 times x, so that's going to be 16x. 16 times minus 2 is minus 32. We're subtracting. 16x take 16x is no x. 3 take 32 is 35. And so that means we can come back up here and say that our answer is 2x squared plus 10x plus 16, and then we've got 35 over the thing that we divided by. Yeah? So in a moment, you are going to go on your merry way and practice some of this stuff. But I want to show you this. No, you'll like this. So can I have our attenzione? This is where everything, I hope, comes together. And you'll be able to work through the next couple of exercises just doing bits and pieces, and I can come around and just chat and get to know you people a little bit better. So right at the beginning, we looked at synthetic multiplication. We can also do the same thing with synthetic division. So here's another division one. I thought I did that in the video and then it disappeared. So then I was thinking, oh, have I done this or did I just dream making up that video? I'm not quite sure. But this is long division anyway. Happy? This is Jack's fave, isn't it, Jack? All right. We did this very briefly at the end of last lesson, but let's just check it again. So if I am doing this question, and sorry, that's faded again. Let me go back up again. There we go. We have two lines here. I put the 2. So I'm just looking at the coefficients of my polynomial. Agreed? So 2, 7, 10, 15. And yes, I'm putting one number in a square. Because I'm dividing by x plus 2, what is my 0? -2. And I pop that there. All right. Underneath the 2, I place a 0. We add. So 2 plus 0, 2. Now we multiply. -2 times 2, -4. What do you think we do? We add. 7 plus -4 is 3. What do we do with this -2? We times. What do we do? Add, times, add, and I always like to do that as my last one. And lo and behold, it's 7. So hopefully you can see the connection, because look at this 2, 3, 4. Look at the 2, 3, 4. What's our remainder here? 7. What's our remainder here?
7.
Pretty grooves? Not so much, some people went. Can we also look at this one? You are going to read and note the remainder theorem when you come to it in your textbook, and I'll pop it up as well. But if I ask you to find P of -2, why am I asking P of -2? Because that's our 0. -2 is our 0. What does P of -2 actually, what's it asking you to do? It's saying go back to your P, so this is my P of x up here, and wherever x is, replace it with, not 2, -2. So it's going to be 2 times what? -2 cubed. I'm going to run out of room. Plus 7 times -2 squared. Now I'm just going to show off. Hope that's enough. Okay, plus 10 times -2. Oh, patience. Hamish, this is your fault. It freezes when it's had enough recording. Oh, Hamish. Oh, there we go. It was nearly goodbye to Hamish. Okay, plus 15. Now, some of you can go to your calculator and get it. Does anyone have an idea before you even go to your calculator? What number do you think, what answer do you think I'm going to get? 7. Are you feeling lucky? Lucky 7. Right? So all of these things are connected. So I might say to you, when the polynomial is divided by negative of x plus 2, it has a remainder of 7. And that's what this would then mean. You could sub it in. Right? What happens if I said P of 3 equals 0? What is the meaning of this? What does that mean? It's really important. When I divide, when it's P of 3 equals 0, that's really, really important. What does that mean? 3 is a root, absolutely. It's a 0, it's a solution, it's an x-intercept, even more, yep. Well, it doesn't need to be the only root because it depends on the degree of the polynomial. But this would mean, see if you can finish it for me, it would mean that x minus 3 is a factor. Oh, And we're about to finish, Hames, because it's frozen again. I think if it freezes twice, we're done. Right? It means that it's a factor. So these three things are all linked together. Okay? And it's going to give you that and work it out. So we'll see how you go. I'll be doing some bits and pieces as we're working through, but you're going to see if you can practice your division. Do you have to do every single one? No. I can guarantee you that there will be one division, long division question in your test, but it's not going to be the whole test, so you've got to spread it all around. So you're doing the time to practice. You can even practice a quad. There will be one in your worksheet, but it's the same process. And then you can see it goes into synthetic division. So it's just the same thing over and over again. If you're doing, I would recommend, as you've done a long division, check your work by using synthetic division, and then listen up, you don't actually have to do 2D3. Well, the first question anyway. Does that make sense? So I think everyone's got enough work to do for now, and possibly for homework, but you never know, I might change my mind in the next half an hour. So get to it and I'll come around and chat.